Okay, this is the second video for Algebra 2A Lesson 1-1. So I found my calculator. So let's go over how you graph these in the calculator. So phone ringing in the background, ignore that. So first you want to turn it on, and then you want to go to this y equals button. And then we're going to do this example 3 right here. So we want to enter 2x plus 3. These are both in slope-intercept form, and you have to have it in slope-intercept form. So you do your 2. This is the button where you get your x. And then plus 3. And then you hit graph. And I can already tell you my settings here are kind of goofy. So let's do this zoom 6 for a standard window. So I want to hit the zoom button, and if you see 6 says standard. So that's what we want to do. And then what it does is it sets your coordinate grid up to be 10 here, 10 here, 10 here, 10 here. So positive 10 for the max, negative 10 for the min here, and up 10 and down 10. So there's my line. Now let's graph the second one. So then you go right back to y equals down to the second y2, and I want to put in 2x and then minus 5. This one should have a negative, no, this one should have a positive slope. No, graph should have a negative y-intercept. All right, well, those are parallel lines, okay? So I can't do this second part where I find the intersection point. That's okay, because these are parallel. So what did we say about parallel lines? We said they never intersect, so there is no solution. And so we describe that as inconsistent. And then we can go ahead and graph these. So y-intercept of 3 up 2 over 1, y-intercept of negative 5 up 2 over 1, and then graph your two parallel lines. Okay? So that's inconsistent. No solutions. All right. Hopefully maybe this one intersects. All right, first thing I notice right away is this is in slope-intercept, but this isn't. So let's do some algebra on this guy and get it in slope-intercept. Solving for y, 4x is furthest from y, so I want a minus 4x from both sides. 4x minus 4x is 0. I'm left with 2y equals, these are not like terms, so I can't combine them. So just write it out. Negative 4x plus 14. 2 multiplied by y, to undo multiplication, I want to divide. I'm going to work to the right here. And so 2 divided by 2 is 1, so I'm left with y equals negative 4 divided by 2 is negative 2x. 14 divided by 2 is 7. Okay, so this is the line I'm going to graph, and this one. Hopefully you're noticing the same thing I'm noticing right now. What happened when I rewrote those? They're the exact same line. So let's graph that. Y-intercept of 7. 1, 2, 3, 4, 5, 6, 7. Slope of negative 2. Down 2 over 1. Down 2 over 1. So there's my line. Don't forget, this is your slope. If it doesn't have a run, if you don't have a run, add a 1. So this is your rise, this is your run. Whenever your slope is negative, go down and to the right instead of up and to the right. Now think back, how did we describe these? We said they had a solution. We actually said they had infinitely many solutions, because these two lines have every single point in common. And we described them as consistent and dependent. Remember, these are like the two friends who have to do everything together. They're completely dependent on each other because they're the same line. All right, let's take a look at this last one. See if this one intersects so we can do those steps we need to learn. Both of these need to be written in slope-intercept form. So I'm going to do this one first. Okay, I want y alone, minus 9x from both sides. That gives me 0 there. I'm left with negative 6y equals negative 9x minus 6. And then, to get y by itself, I want to divide everything by negative 6. Negative 6 divided by negative 6 is 1, so those 1 out. Negative divided by negative is a positive. So I'm going to write that as 9x over 6. Negative 6 divided by negative 6 is positive 1. This fraction can be simplified. So one more step, let's simplify that. 3 divides into 9 3 times. 3 divides into 6 2 times. And I'm going to write it like this. Instead of that x up here, I can write it as 3/2 x. Then it looks more like slope-intercept form, and I know my rise is 3 and my run is 2. Plus 1. So there's the first line I want to graph. Now let's solve this one for y. Same steps, minus 6x from both sides. Negative 4y equals negative 6x minus 4. Now I want to divide everything by negative 4. Those 1 out, and I get y equals 6/4 x plus 1. Negative 4 divided by negative 4 is 1. This fraction also can be simplified. 2 goes into both of those. I'm left with 3/2x plus 1. Oh, this is another example, like the one above, where I have the exact same line. So let's graph this. Y-intercept of 1, slope of 3/2. So rise 3, run 2. Up 1, 2, 3/2. Okay, graph your line. And what did we say? Same two lines on top of each other are going to be consistent because there is a solution. There's actually infinitely many solutions, and it's dependent. All right, I want to show you how to find the intersection point for a line that intersects. So I want you to go back to example 2. And we're going to put these two lines in the calculator. And we know they have an intersection point. We're going to find it on the calculator. So I want to go to my y equals. I want to clear these two lines I had in there. Here's your clear button. Okay, now the first line was x minus 3. So I'm going to graph x minus 3, and then I'm just going to go ahead and put the other one in right now, and that was this one, negative x plus 1. So negative x plus 1. When you're putting in a negative, make sure you're using this button and not the subtraction. If you use the subtraction for a negative, you'll get an error message. So make sure you did negative x plus 1. Okay, now let's graph these. Okay, now we can see they intersect, but we want to make sure we find that exact point. So that's what these steps here are describing for you. So to find the intersection of your equations, hit second, that's this button, and then trace. So what you're choosing is this calc. So second trace, and I want intersection, menu item 5. So you can go down to 5, or you can just hit the number 5. And then I want to hit enter. And then it's going to ask you, what would you like me to find the intersection of? It asks you the question, first curve. It uses the word curve, even though these are straight lines, that's okay. And then you can see your little cursor is blinking right there. So I just want to make sure it's on one of my lines. And I say enter. Yes, I'd like you to find the intersection of that line, so hit enter. And then it's going to say second curve. So now I want to move, you can see there, now it's on the other line. So then I want to say, yep, that's the other line, and I hit enter. And then it says, would you like me to guess? And you hit enter again. And it tells you the intersection is at 2, negative 1. And that's exactly what we found when we graphed them. So that's how you use the calculator to find the intersection. Okay, that's all the examples for 1-1.